Hello, everyone. We are going to have another session in Microsoft Euro community. So my name is Priya, Microsoft MVP, MCT, and community leader in Microsoft Euro. This is the first session of APAC series sessions during this September. So before actually having Santosh or great speaker on the stage, so I'm going actually to a couple of actual rules of the community and talking a bit of the community, and then we are going to have Santosh on the stage. First of all, Microsoft Learning Community, as I mentioned a couple of times before, is a perfect place to grow your skills, connect with the Microsoft experts, get the real support on your learning journey. For those who already actually know about the learning rooms, as per recent changes, again, the Microsoft learning rooms are now moved to the Microsoft Tech community, and you should be able to follow Microsoft Zero to Hero there too. So make sure you watch actually that the space of the Microsoft Learn is great actually topics, great information by Microsoft and experts there, so you can take advantage of it. A bit of code of conduct. So the same as any other communities in the community space, we ask everyone to be friendly, respectful to one another, listen to different opinions, and be kind and patient when asking or answering questions. So without further delay, I would love actually to bring Santosh on the screen. So give me a sec. So Santosh is going to actually cover up for today about the Fortifying your cloud, mastering Azure network services to protect your application. Santosh, great to have you today here. How are you?
Thanks, Boya. Hi, everyone. Good evening, good afternoon, wherever you're located.
Awesome.
Thanks for
Thanks,
having me,
man, for
Boya.
joining us and sharing your knowledge here today. We are very excited to hear what you have in your plate for us today. And we are eager actually to
Sure.
hear your greatest story today. Awesome.
Yep.
Give me
I'm
a
I'm
second. I'm
I'm,
just
I'm
bringing
pretty
your
excited actually.
slide up.
Slide.
And I'm going to be behind the stage. Let me know if you need anything. The stage is yours. Thank you.
All good, Boya. Thank you. Hi, everyone. Good afternoon, good evening, wherever you're located. Thanks for joining the session, taking time out. Today's session is about how do you mastering with your Azure networking services to protect and deliver your applications. Because that's a session. Just before we get into anything, I just want to quickly give you my intro. I'm Santhoshkumar. My name is so lengthy. I can call me Santosh. I currently live in Melbourne from Australia, basically from Chennai, southern part of India, and hold my MEP for Azure networking and cloud security. A dual MEP. This is my second year, and I specialize in infrastructure and security, mainly focusing on public and hybrid clouds, with around 18 plus years of experience. Other than the technical and professional stuff, you can find me anywhere in the cricket ground, or you can just get some blogs, emails from my LinkedIn post where I just provide my insight. That's about me. Let's get into the agenda for today. I just gave my introduction, quick about me, bio. And today we're going to cover about the components of Azure networking services. I'll give you overall picture. And in specific to that Azure networking services, there is something for delivery, which how do you secure your application before it been exposed to the public internet? What are the rules and things that has to be guardrails, governance, security has to be taken care. We'll speak about Azure Load Balancer, Azure Application Gateway, WAF with a front door, and Traffic Manager, and a small demo. And we'll just summarize what is the key takeaway from today's session. Okay, let's dive into this. As Azure Public Cloud, there are multiple networking services which helps to each of the organizations for the persons to have their own set of things running in cloud, and it has various services, and it has been divided into four subset. We call it in that way, or services which been categorized. The first one is connect. As the name predicts, it's connectivity. You need to have connectivity from on-premise to the cloud, or from any other locations to your cloud. You can use virtual network, VWAN, express route, VPN, DNS. Those things fall into the connect services. The second thing is protect, which helps you to protect your application. How do you protect your resources, infrastructure, services, what you've been hosting within Azure? That can be like example of Azure Firewall or any other network virtual appliances, Firewall Manager, NSG, Private Link, DDoS protection, and WAF. WAF is a little peculiar. It can be go across your delivery and protect as well, but we keep it in protect as of now. And the third section is delivery, where how do you deliver your applications back to the end user, the customers. That helps with multiple services, load balancer, Azure Front Door, traffic manager, and application gateway. As you see all those names, right? The WAF will be, it's a combo which works diligently with these services. So WAF can be played across protect and deliver. And the last bit of the networking services is monitoring. We need observability. We just want to make sure whatever we do is been having a auditing and logging to make sure it can be used whenever there is a need. So with this is the Azure networking services we categorize into four, and my focus is on the load balancers, front door, traffic manager, and the application gateway. That's our session today. As I mentioned, the today's session is about Azure Application Delivery Portfolio, which comprises of these four services. In addition, the WAF will be a combo of with all these services wherever it's been applicable and can do some security services on top of the networking one. Application delivery portfolio can provide you an application delivery services to let you build mission critical for dynamic and high performance across your globe, making it available on always on. Okay, let's get into this. So we have four different things to cover it up. Let's do start with Azure Load Balancer. As the name implies, it just helps you to balance your application loads. It's acts in a layer 4 on OSI model. Load balancing is a service distributing your incoming traffic, TCP, UDP, across your backend resources. It provides high availability, ultra low latency, health probing, and supports both private and public. The probe is a key factor in load balancer, which helps you to detect is the VM is active or healthy. If it feels that the probe is not active and healthy, then the response of the application will not be transferred back to that specific backend service. It will just shift it to the other service which is active and healthy. The probe is a key factor here. And the load balancer can be deployed into two different things like public, which is an external, which has a public IP address, which is available to the end customers on across the globe. You can access it from the public IP address or the DNS if you have against it. The second option is internal, used within the virtual network and not accessible from the internet. There are two options. As I said, the health probe plays a major role. The built-in health probes constantly monitor the health of the backend resources, and it just helps you to have the application always on and ensuring the traffic is only sent to the healthy backend region. It won't send any other things if it is an unhealthy one. If the probes are not responded to the instance, will be taken out of the load balancer as providing a response back. And the probe as mentioned, right? You can have your custom probes, which provides ability to detect the application health, and the custom probes are supported in TCP and HTTP. So if you're using a custom health probe, you can keep the network load balancer from putting the machine into load balancer rotation until it is readed by or non-returning of 200 HTTP code. That way it helps. Okay, the next thing I want to give is on the load balancer, the SLA is 99.9%, and when it is deployed with at least two regions with the healthy backends. Other thing I want to highlight is the cost. It's based on data processed by the load balancer and health probe data volume on outbound data if there is anything. So that's about load balancer. It just works in a layer 4. That's where it just makes your application available on TCP and UDP ports. Okay. Let's see to the next slide. We have multiple load balancers types and SKUs available in Azure. I can say three because the primary or the first one as part of here in the slide, you see that basic load balancer has been retired. The basic tier load balancer provides a basic feature. It is restricted with some limits and backend pool size. It restricted only for 300 instances in the backend. It is bound to have single availability set. So with all this, on September 30th of 2025, the basic load balance is getting retired. So The first thing, if you're having your basic load balancer anywhere in your Azure services, just go and migrate that to standard load balancer. That's the first thing, key takeaway for today. The rest three load balancer SKUs are standard load balancer, which is quietly popular to have this standard load balancer. The standard tier is generally available. It offers higher scale and all the features. There is no limitation. We already spoken basic. Everything is taken out here. Standard load balancer. It's paid for the future using complex set of consumption based charges. Also, we can scale out up to 1,000 instances in the backend, can span any virtual machine in a single virtual network, including the scale set, availability set, or any other appliances you want to be using it as part of your application hosting in the load balancer thing. And it supports for availability zone and which provides high resiliency. Standard load balancer offers a zone redundancy as well. It is a regional resource. That's a key thing to make it up. And I'll cover something more in detail if you go there. Standard load balancers are high performance HA. It provides outbound NAT rules and it supports private link as well, which came recently out. The second one is the gateway load balancer. It has been designed for mainly for the network appliances like transparent insertion of the third party network virtual appliances or firewalls or DDoS appliances, and it supports service chaining and flow of symmetry with VXLAN. I'll just cover more in detail about the gateway load balancer in the coming slides. I'll just give you a high level here. The other thing on the SKU is the cross region load balancer, which provides a single global layer for any cast endpoint for distributing traffic across multiple Azure regions. This is a global service. Use Azure Backbone to route the traffic to the nearest healthy region so that it can be across your multiple region, which provides HA and efficient performance for the global application. And the other thing is on the standard load balancer, there is something called cross subscription load balancer, which has been on GA from last year, November 2024. And what does it brings in different of this is in the standard load balancer, when you enable it, the front end and the back end pool instances can be in different subscriptions. So by default, earlier to this feature is available, you have to have all your backend instances and the load balance in the same subscription. With the cross subscription load balancing option or the future, you can have the backend be in different subscription within your tenant. So that way, your load balancer can be in a different subscription, and your application layers and the instance of the backend can be in a different subscription. So these are the four load balancers SKUs available, making sure your basic load balance is getting retired by end of the month. That's a key takeaway here. Let's see how Azure Gateway Load Balancer works. As a name indicates, it's a load balancer that enables you to have it for your virtual appliances where you insert your traffic with the path reconfiguring for the route and clients. It simplifies the service chaining for the third party appliances, wants an advanced security and inspection of the traffic before it goes back into the backend resources. That's a primary use case. The primary use cases like firewall instances, intervention IDS, IPS services. If you want them to have some kind of a load balancing between that, then the gateway load balancer is the preferred way of doing it like it way. The gateway load balancer sits between your standard load balancer and your backend VMs app services. It uses the VXLAN encapsulation for forward traffic to the virtual appliances. The virtual appliances process the packet and it returns back to the gateway load balancer, which then forwards back to the backend service or the systems which is in the backend. So that way it ensures the flow symmetry, which preserves the original source IP and completely transparent to the client and backend. So that way you have some kind of an additional security which sits between your workload and the load balancer. That way it just has some traffic is inspected. Gateway load balancer is pretty much used in your network firewalls and IDS and IPS scenarios. Then last one is Azure Cross Region Load Balancer. As a name implies, it is works across the region. It is global load balancer, which provides in layer 4 option. It is different. It can work from multiple regions. Say suppose you have one in Azure, you have your backend instances Azure in Australia, Azure in Singapore. You want to have some kind of a global load balancer. Then with the layer 4 is required, then the Azure cross region load balancer is the preferred way to go in that path. Azure cross-region load balancer has single unique globally anycast IP address to the load balancer across the Azure region. It helps to load balance distribute traffic to the closest region, ensuring the low latency when the service has a backend application has been consuming or it's been accessing. By incorporating Azure cross-region load balancer in an end-to-end architecture, the customers can achieve the region redundancy and high availability, low latency for their application to be with the quicker turnaround to the closer to specific of the geographic. So if the one region fails, the traffic is routed to the next close healthy region because the probe works here again to make sure the backend service is healthy and it is active. The health probe of the cross regional load balancer gathers the information and makes that availability of each regional load balancer. The probe can access the backend to make sure it's healthy. Probably around every 20 seconds, it just goes and makes sure the backend instance is active and healthy. If one of the load balancer drops the availability to zero, the cross region load balancer will detect that backend instance is a failure and it just takes out of that backend instances from the backend pool and the application will not be served to that backend instance. The key factors on the cross region load balance is low latency with geo proximity, a routing algorithm, automatic failover for disaster recovery. You can scale up and scale down with no downtime. So these are the key things with Azure cross region load balancer. With that, we are coming to end with Azure load balancer service. The key takeaway: basic subscription, basic SKU, not subscription, basic SKU is of load balancer series is getting retired. Make sure you have a migration path planned for it. Cross subscription, you can use load balancer across your different subscriptions within a tenant, and the cross region load balancer is one of the key features. And with the standard and other load balancer tiers, you can use the zone redundancy. So the load balancers are zone redundant. It can provide you a bigger and a better resilient on your applications. With that, I'll move to the next section, which is Azure Application Gateway, which is one of my favorite topic out of this services what we've been discussing. Azure Application Gateway is kind of my most favorite, which has been used across widely. As the name implies, this is a web-based traffic load balancer. This service has been operate on the layer 7 OSI model, which can be used for performing your URL-based routing. So the one question should come up by default is what is the difference between the load balancer and the application gateway? The key difference is load balancer can act in layer 4, whereas Azure Application Gateway will be acting on the layer 7, which is on the application layer. So that's a key difference. And it is platform managed. It is built in HA. It supports zone redundancy and scalability. And this service as well can be used in a public, internal, both on public internal, or you want to use it just for internal. It supports all the different scenarios. And the flexible backends, what are the backends Azure is it can support? It can support VM scale set, AKS, anything with the public IP address in Azure, any cloud services or Azure load balancers or internal load balancers, and with on-premises public IP address. So what is Azure Application Gateway? Azure Application Gateway is fully managed layer 7 HTTP and HTTPS protocol, web-based traffic load balancer, and you can call it in the way of as a reverse proxy. It handles advanced routing such as path-based routing, TLS termination, header rewrites, and integrates with web application firewall, which provides an additional security for your application on the layer security, application layer security. So when I say path-based routing, I can give an example. Say you have a website, you have multiple backends on it, and when someone hitting on your website and want to have some kind of a uh, gallery of photos, videos, you can just point that for a specific backend instance, whereas your home folder will be on different backend instance. So when someone hits your public application service or the website in the home page, you land on backend A. And when someone wants to view your photos, a gallery of videos, some other images which has been part of your application in your website, you can just have a backend for a B, so that specifically on the path base, you can route the traffic back to the specific backend services. That's the key thing which application gateway works. The other additional features on the security wise, right? When you have a Azure Application Gateway, it supports SSL termination. You can do an end-to-end TLS from the client to the backend, and you can do HTTP load balancing. And as I mentioned earlier, you can route the path-based URL, and you can have multiple sites. And it provides public and private. You can use it for application gateway with both public and private, and it supports auto scaling. And the bigger thing is it has an integration with the WAF, the web application firewall, that protects your layer 4 with cross-site injection, SQL injection. All those predominantly used in layer 4 7 for an attack will be filtered out, and it provides an additional layer of security in your for your application. The other key thing to be noted, Azure Application Gateway has two SKU, version 1 and version 2. Version 1 has been announced retirement for 2026 on end of April. So this is another good time to have a migration planned for legacy SKU, so that you can just move out without any downtime or any kind of an implication with this. That's a key takeaway here. Application Gateway V2 SKU offers an additional features which like auto scaling, availability zone, redundancy with higher performance. All those things has been lagged in V1. So V2 has its zone redundant, and auto scaling is supports in this way. To set up an application gateway, what are the key features or services you required? You need an application gateway to be deployed within a specific subnet, a dedicated subnet just for application gateway. The sizing is required is minimum as /26, and it potentially reserves /26 subnet for it. So you need to have a dedicated subnet. That subnet cannot host any other Azure resources except for application gateway instances. And mixing the V1 and V2 is not supported in the same subnet, so it's always to have a segregation of V1 and V2 in a different subnets. Application Gateway supports both public IP and the static IP with the private endpoint as well. You can configure up to two IP addresses, public and private, and two IPv6 for the application gateway. Okay, let's go to the next slide. Just want to cover up some additional application gateway steps. I think we spoke about a lot here. Like auto scaling, which can grow and shrinks based on the application traffic requirements, and there is no need to provision or something. It's just been platform managed. It provides high performance SSL offload, end-to-end TLS. Uh, End-to-end TLS has been supported. Coming back to the cost management, the V2 billing is split into fixed cost for the provisioning of the application gateway and the capacity units based on the usage. The idle gateway incur a fixed cost part at very minimum, and factors for you just want to make sure that has been factored. Even though you're not using it, there is some fixed cost when you provision application gateways. Been there is a fixed cost involved. And again, application gateway is similar to the load balancer. There is a health probe, which is be used to be making sure the reliable backend endpoints is being active and healthy. And so that way, it just provides and makes sure the backend behavior has been healthy before the traffic has been diverted to the backend. Treat application gateway as a bounded resource to avoid hitting service limited. So use a dedicated instances per team. That is another key takeaway. You have to use, you can't have a single application gateway for entire organization. You have to have it dedicatedly for your specific application. So that way it solves a couple of things like you can have an RBAC and that has been dedicated for this specific team. And other thing I want to highlight with application gateway, right? The TLS 1.0 and 1.1 has been retired. So it's always best to have 1.3 is the latest, or at least with 1.2. Azure Application Gateway will never support TLS 1.0 and 1.1, and the backend must use at least 1.2. And if you have an Azure Application Gateway with the version 1 SKU, there is an migration path which is an ongoing, and it is provides you direct migration from V1 to V2, and there is a Microsoft Learn page to get some information about that. With that, I want to cover up the another SKU within Application Gateway, which is for Application Gateway for containers. As the name implies, this application gateway is specifically for the container-based application which has been hosted in Azure. Uh, the AGC is what the shorter term we call it as. That's what the picture is predicted here. I mean, implication here. AGC is a specialized layer 7 load balancer solution optimized for container workloads, especially within AKS. It evolves from the older version of its name is Application Gateway Ingress Controller, that is AGIC. That is the older one that has been kind of it is still active. It is not retired, but Microsoft recommends to use AGC because the layer 7, the ingress solution is supported in AGC, and AGIC doesn't support the ingress solution. And you can have WAF enabled with application gateway for containers, and you can have secure MTLS and mutual MTLS as well, and you can have your network policies defined. And Azure application gateway for containers supports in two options. One is bring your own, where you explicitly provision the AGC, the front end, and you have your own AKS stuff where you can just provide a link between that, and you can have granular control of your resource lifecycle. So you could just take that way, or something is managed by the ALB, that is Azure Load Balancer. Azure Application Gateway Load Balancer, where that is deployed within your AKS cluster. So there are two options. You can provision AGC, the Azure Application Gateway, by within your Kubernetes resources, by your infrastructure as code, or if you want to have it your own controlled one, then you can deploy AGC separate, and you can have Cube or the containers resources separate. Then you can just combine this for your application security. Again, the key features and capabilities what we spoke earlier on Azure Application Gateway, pretty much everything is covered here, like path-based routing, query routing, and redirect and rewrite can be applicable, traffic splitting, and the mutual TLS like end-to-end TLS is also supported. And again, the TLS 1.1 is minimum. No older TLS version is supported. You have to be very sure about it. And that's the core features. And WAF is currently enabled on Azure Application Gateway. I think it just came out of preview recently. I think it has been in preview now, but it is good to use it on this. And again, it is auto scalable, zone redundant, auto scaling is available. With that, we are coming to end with Azure Application Gateway section. The key takeaway here is make sure you have WAF combined with Azure Application Gateway. Make sure the subnet have a dedicated subnet for Azure Application Gateway, and make sure there is no UDR is being enabled on that specific subnet. That makes your application gateway to work stop. And you can enable mutual authentication like mutual TLS, that's been supported, and private link can be enabled on your Azure Application Gateway, which can provide you the direct access within the private link. There is no public has been involved. Enable the WAF policies at the edge to block the common web attacks. Centralize your TLS and SSL termination. Make sure you deploy the V2 version of your Azure Application Gateway. And when it comes for the containers workload, make sure Azure Gateway for Containers has been used over Azure AGIC. And again, health probes with reliable endpoints, making sure proper backend endpoint has been active. That's other thing. Best practices, just make sure as auto scaling and zone redundance be enabled by default, health based design, no UDRs, and enable WAF. That's with Azure Application Gateway. So far, we just covered two sections. One is Azure Application Gateway with load balancer, and the third section is Azure Front Door. This is another my favorite. I can't just keep go on with favorite, but still, Front Door is my favorite. I've been working from Front Door from 2019, which has been came out of the service for GA, and I've been active in using in Front Door with most of my customers. So Azure Front Door, what's the different? What's the service? Let's go in that. Front Door is a globally fully managed layer 7 entry point which provides Azure Azure Application Layer 7 plus the CDN. the content delivery, the dynamic and static acceleration of your application load balancer with the WAF protection, with SSL offloading, with the global failover. That's a key here. With the application gateway, it is regional based service. It is not a global based service. So, for example, when you have an application which is running in Azure Australia, and you have another application for the DR or active in multiple regions like in Singapore or in Europe, then you need to have two different application gateway. And if you want to do a failover from one region to another region in application gateway, that has to be manually have to do a changeover of the DNS. But with Azure Front Door, you don't need that because it is global region. You can just have a backend from one region and backend can go another region. You can look at this diagram which clearly explains that. That's a key difference between Azure Front Door, and that's a big difference which someone wants to have an application across a multiple region with active or active passive without manual intervention. Then Azure Front Door is the key. In addition, what you can do is if you want to have an application gateway in regional, and you can have a Front Door on top, two different application gateways from region A and region B, but the entry point is on Front Door. Front Door will decide which is active and make sure the traffic is split across to the different location. It provides improved performance, reliability, and security for application, routing the traffic to the nearest and healthiest backend. Provides load balancing, SSL, offloading, application acceleration. Because with this, you treat this Front Door as a global HTTP load balancing with instant failover across the region. In addition, it provides WAF, and it can work with the DDoS protection as well. And Azure Front Door has the cloud content delivery network, which provides a dynamic and static of your web content, which has been across the globe. And Azure Front Door has three different SKUs, kind of classic, the Front Door Classic, and Microsoft CDM Classic, and the premium one. The premium and standard tiers are two tiers, and the older tiers is what I was saying about the classic version. What are the key features of Front Door? The first thing is global load balancing. It routes traffic to the nearest, and from multiple region, you can have an active, and you can just make sure whichever is a priority. So the routing method supports in here is geography, healthy checks, and latency to ensuring the best performance for the users across the worldwide. And second thing is the dynamic site acceleration. It accelerates the delivery of dynamic content, improving the user experience. Say, for example, someone you're accessing your website from Europe and you're hosting it from Singapore. The first time will be slightly higher latency. Then if someone access and another user access from somewhere in Europe, right? This application, the content is being cached in the CDN, and it has an edge location across the globe in Azure that provides a quicker and faster accessing of your websites. And it provides SSL termination, offloads SSL encryption and decryption, reducing the latency and CPU overhead on the backends. And the bigger thing is on the layer 7, it has a global service, and it provides an instant failover. If the alternate regions on the backend is goes down, it just forwards back to another region. But in Azure Application Gateway, it is regional. Front Door is global service. Azure Front Door provides with two SKUs, standard and premium tiers, which are released in March 2022. And the classic tiers or the older tiers are like Front Door Classic, CDN Classic. Classic has been legacy version, and it's not supposed to use from April 1st of 2025. Just keep in mind. Standard provides the content optimized and offering features with all the things comes up, and the premium has an additional like private link is comes as part of premium tier, and the integration with Microsoft Threat Intelligence and advanced security analytics are at no extra cost within the premium. When you grow premium, it has everything. Let's go in just more detail into Azure Front Door. As I mentioned, Azure Front Door can work with WAF. WAF for Front Door is like a global and centralized solution. You have that protection for the application layer security. WAF can have rules like you can detect and prevent. If you have detection mode, this mode does not take any action based on the rule. It simply monitors and logs the request. It won't stops there. It will just pass on. In the prevention mode, this mode takes a specific action based on the rules defined, and if the match is found, no other rules are evaluated. If there is an application which has been hitting on it, and say if it is not allowed, it just blocks there. Azure Front Door provides web application firewall capabilities to have combinedly work, which protects your web application from exploits and vulnerabilities and any kind of malwares. Managing the security of application can be challenging because web applications are increasingly targeted nowadays with the cybersecurity threat. So always have some kind of a WAF in addition to this your application to make sure the incoming request is being on WAF enabled and the application delivered by Front Door is inspected at the network edge locations. Okay, this diagram is one of the favorite diagram in Azure Front Door. If you look at here, right, you see the blue dots here. These are the edge locations across the globe where Microsoft has their own presence in across the region. And these are the Azure data centers across Australia, wherever across you call it up. Even though there are some locations where they don't have data centers, they have edge locations. What happens is these edge locations helps Front Door to have a highly available application and it's been delivered across the globe. What happens in this way, right? When someone accessing an application in Europe and your site is being hosted in Singapore, it first time it just grabs that information of the site as a CDN in the front door and keeps a cache in your edge location within Europe. When different person accesses it, it just gets that cache and just delivers the application back to it. That way, it is dynamic and it is very fast acceleration. That is the major thing with front door. And the routing methods are available within front door or latency, which ensures requests are sent to the lowest latency backend within the acceptable sensitivity range. Second option is priority. This priority is defined by the administrator saying like this region is my priority. You have to always have your backends based on the priority. The third one is weighted. Is again assigned weights to your backends. When you want to distribute traffic to a set of backend, you can assign higher or lower weight. That way you can just dedicate your backend to that actually. And if you want to enable session affinity, allows you to configure this user session affinity to your front end host or the domains. This helps ensure the request from the same end user are sent back to the same backend. And in addition to that, Azure Front Door always provides a backend health monitoring option. Azure Front Door periodically assesses the health of the backend resource for the configured, and response from the backend enables the Front Door to determine which backend resource should this access or the application should be transferred. If the backend is not healthy, the application won't be sent back to that specific backend. Okay, we spoke a lot here on the front door. The front door, just to summarize, it's dynamic site acceleration. It provides CDN. It's a global filtering, and it has WAF, and it is a global application delivery across the reach across the globe. Let's give an architecture example here. You see here the content. This is Microsoft architecture document, which the website is here. You're hitting it, the edge location. It gets a specific from your primary location and gets all this information back to here. You can do a path-based routing for search. You can have this specific backend. For statics, you can go for a different backend. That way you can do this. In addition to this, the other point I want to highlight is the front door. Front door not only works within Azure resources at the backend, it can work with on-premise. It can work with anything with an public IP address. So in that way, you can just bring an on-premise backend resource to your application. You can have something like your primary site is your Azure and your secondary site is your on-premise. So that way, front door works. I want to give another interesting fact with the front door. Any service currently using in with Microsoft, with M365 or any of the OneDrive, Xbox, Bing, LinkedIn, all these services are using front door for their application delivery. You can just imagine LinkedIn, it's pretty much fully with front door across from the globe, anywhere it has been, it just uses front door. Xbox, OneDrive, and most of the M365 apps are using it, Azure Front Door, for there to deliver their application. Okay, this picture gives you the enterprise version of what is happening in the backend with the front door, how the application is getting transferred to the end user. So Here the user accesses it and it goes back to the front door, and front door will have its edge sites across the location. It's not data center, it's edge location, making sure it's kind of a point of contact for that specific load balancer or global load balancer. It has all the protection, proxy, DNS, caching, everything. It just goes and gets it from the data center, and it just does a probe here, making sure it is active and backend is healthy, and gets the information. Once it has it, it has a cache and just responds back to the user. This point of map, the map of the intent here is making sure if one region is down, it just transfer that request to the another option. It just has a fast failover. It's actively monitoring. This is pretty much Azure Front Door uses all the Microsoft Global Edge Network with hundreds of global and local points of presence distributed across the world, which close to enterprise and consumers of to use the application. So we just seen three different services so far. One is load balancer, which works only with layer 4, and it provides global load balancer as well, with which one only on with layer 4. Second thing is application gateway. That's a regional based layer 7 application load balancer. It works on the layer 7. Azure Front Door works on layer 7. It is global. It works with the WAF. It has a CDN content enabled, which provides dynamic website acceleration for you. And this supports active active or active passive. And similar to the application gateway, it supports private link enabled and WAF and geofiltering. Make sure you have WAF enabled with your layer 7 services in Azure to make sure you have an additional security on your application layers. And just to quickly remember, on the front door, you have standard and premium tiers. And if you are in a classic version of this SKUs, there is a migration version. Migration option is available. Zero downtime. You can just do that, and it is best practice to make sure it's before it's get duplicated. You are just migrated to the standard and available SKUs. Okay, this is the last section of here. So, fourth section I mentioned Azure Traffic Manager. Azure Traffic Manager. This is a DNS based traffic load balancer. This distributes the traffic to application endpoints, improving the application availability and responsiveness based on the DNS query. It directs the client request to the most appropriate backend based on the configuring routing methods and endpoint health monitoring. Again, there is a probe here as well to make sure the backend has been monitored, active, and healthy. This you treat this as a global DNS based load balancer. That's it. Traffic manager works by applying an intelligent policy engine like within the DNS, queries to the domain names of your internet resource, and your Azure websites can be running in different across region. And that way, if you have, say for example, this is your traffic manager, and user is querying a website, and it just goes and gets a DNS service, and with that health check, make sure this is your primary and this is your failover region. If it goes down, the secondary region traffic will hit. The difference between so far we discussed front door and application gateway load balancer is this is a DNS based traffic load balancer. The traffic manager uses DNS to direct the client request to the most appropriate service in the backend. The traffic manager provides a range of traffic routing options, which we'll be seeing in the coming up slides. And I'll explain about more about the such as priority, weight, geographic, or the subnet or multi-value. Traffic Manager is a global service again. It is resilient to failure, including losing an entire region. Even if it's one entire region gone, it is a global service. It can provide you a resilience. It improves application availability and the performance. Okay, let's see what's happened to them more in detail. How Traffic Manager works. See, when the user accessing an application, it just hits the traffic manager and the DNS query, and it just hits the DNS response back here. The traffic manager verifies the DNS response, and it routes the traffic back to a specific backend here. Works by using the DNS, direct request for the most appropriate endpoint, select the endpoints based on the available, healthy, and healthy, making sure it's been automatic failover if the health of the resource of the backend has been failure. As I mentioned, Azure Traffic Manager has multiple options in their priority routing. I'll show you a demo on how that works exactly. The traffic routing methods are priority. Priority, as the name implies, you'll have a primary service endpoint for all the traffic, unless if your backup endpoint is only for the if there's a primary goes down, the secondary hits on the priority. Geographic based, it selects geographic routing direct users to a specific endpoint based on their DNS query originating from specific geographic location. Say for you have an application hosted in Singapore, you want to make sure anyone accessing from Asia is you are hitting the Singapore backend region. And you want something for performance like select performance routing. When you have endpoints in different geographic location, you want to have the users to the closest region, similar to the geographic, but you are not defining here the geographic. It is based on the performance from the specific user to the backend. Weighted, what happens is when you want to distribute traffic region on set of endpoints on their weight, set the weight for this specific backend to distribute across the traffic. And the multi-value is like you can have only traffic managers select multi-value option for traffic manager profile that can only have IP4 and IP6 addresses as endpoint. When the query is received for this profile, all health endpoints are returned back to them. It's a multiple value. And the last option is subnet routing. This method is to map a set of end user IP address range to a specific endpoint. You have a specific public IP address, you want to bound that to a specific backend, you can do that with subnet routing. So these are the different options within Traffic Manager. So this diagram gives you about what is weighted routing. I'm just picked up one routing option here. So the user queries, DNS query goes to the traffic manager and goes back and verifies, and you have weighted option of A. Region A has weighted of higher, so anything has to come here, but the status is goes to degraded. The backend instance of the region A is not healthy, so the request will not go here even though it has been weighted with higher priority. Then it goes to region B, which is the second highest priority, and the last one is a test A. So that's how it works with the routing methodology. The key takeaway here is make sure what routing methodology to be used in your application based on your scenarios, your application requirement, how do you want to deliver a bit back. Choose the routing methods based on the business goals and performance or availability and control. Use the health probes. Make sure the traffic manager can be used on Azure and non-Azure endpoints, and it can be used in active and active passive. Okay. Trust me, this is the last slide. Azure WAF. We spoke WAF on multiple points. I just want to give you a recap. Azure Web Application Firewall is a cloud native solution that helps to protect your web application from common web vulnerabilities like SQL injection, cross-site scripting, and bot attacks. This can be integrated with Azure Application Gateway and with a Front Door, which can provide you an additional layer 7 protection. So that way it works with Application Gateway as well as your Front Door. It can work on both. So make sure you have this enabled as part of your application delivery services. Okay, time for a demo. Let me bring my browser here. This is my Azure portal. I have my Front Door available, created, and I have my traffic manager created. I'm not a developer guy, so this website will be just pretty much simple. Don't expect something like too fancy websites. I'm not a developer. So this is okay. This is my Azure Front Door. What I have done is, okay, I'll show you here. I have my Front Door. If you look at my origin groups, I have two backend resources. One is created in Azure Australia region in Sydney, and the other one is Azure Singapore region. I'll show you my backends. Okay, I'll go here. you can able to see my backends, and it just provides you the health probe, which is active, or if it is degraded, if it is down, it just shows here. I have my Australia East is my priority one. My Singapore is my priority two. I have my health probes created. That's fine. Okay. If I go and hit my Azure Front Door, it just goes back to my primary region. You just see here, this is a community demo for the primary region. Perfectly works. That's perfect. And I have my traffic manager. I'll show my configurations. What I have is, I'm just using the same backend pool here. It looks little slow here. I'll go back again. My traffic manager, which is again the traffic manager and friend door as a global services. Methodology as a geographic. What I have done is, before it just comes up, I just want to explain about what I have done is my primary site Australia. Anyone accessing my website from Australia will be the Australian backend, and anyone accessing from North America and North America will be again Australia. Other than that, I just given it Singapore as my source. So anyone accessing from UK, Europe, Asia, Singapore, that will go back to my Singapore region. Okay, I don't know something. It's just taking some little bit time here. Let's go. What happens here? I'll show you. This is my traffic manager. Don't take as best practice here because I don't have my SSL here. Just this is for my demo. I have my URL copied here. So if you look at here, I'm just using. This is a different browser I just came through, which can take you on testing it purposes from different locations, irrespective of where you're located. Actually, so this is my backend URL. I'm just selecting from Japan. You can select the regions where you wanted to select. Japan, from Singapore, from Germany. I can six select. I can select 6 countries here to make sure my testing works fine. So if you're accessing from Canada, it just lands in my Sydney region, the primary region. If you access it from Germany, lands in Singapore. Someone from Singapore, it lands in Singapore again, my secondary region. If someone from US, the North America, it lands into my Australia region. So you can select different routing methodology here. For some reason, it just got stuck here, guys. I'll go back and I'll open it again with my traffic manager. I'll show my configuration. So yeah, that's the end of the. Look at my endpoints. At least I just want to show you what is the routing methodology I used, and that's how it works based on the testing up here. Um, Pretty much that's it. My demo. I think. Sorry, guys, it's just taking some time. It doesn't loads up properly in my Azure portal. Make sure my WAF as well. Make sure your WAF has been on the prevention mode. Don't use it for detection mode. Detection mode can be used for your development, all kind of testing, making sure that's been tested everything. And if you have anything to want to tweak it, just make sure that and just enable prevention mode. Don't have it in detection mode for a production scenarios. Just ensure that it's been prevention. Okay, let's come to my slides. Here a demo. This has been given by Microsoft or Azure team for someone who wants to make sure which service to be used on what is your application. So let's take this like as a starting point. If you want to have something like a global web load balancer with multi-region for media streaming, you just use Verizon Media Streaming. That's just not load balancer 7 or anything on the network services. If you want to use global web load balancing with a multi-region, if it is yes, you go to making sure do you require SSL offloading an application layer processing per request. If you don't have that option, just front door. If you're a global web load balancer, no SSL offload or application layer anything, just use front door. If you are a want to have a global load balancing and you want to use your SSL offloading application layer and you want to do the CDN as well plus the WAF, then front door plus application gateway. I mentioned earlier is this. Application gateway can work with the front door. So your front door is your primary and your application gateway will be sitting behind the front door, which acts as your backend. And if you don't want to have a global load balancer, it's just web load balancing with the request within the VNet. You want to have SSL, then it just pretty much it is application gateway to be used. And make sure you have WAF against all this. That's it, guys. Just thanks for attending. Key takeaways: enhance the security posture of applications by using WAF and front door and application gateway, predominantly based on your business goal. But at least I want everyone to make sure you have WAF and front, which has been publicly used accessible application, and it improves your user experience through optimized routing and performance. And it has been you can have all these services collectively, which can help in fortifying the security and performance of the application. Now, another point I want to highlight is make sure you always enable the monitoring and auditing and logging so that if you have anything, you are stuck on something, you have to make sure that's been enabled for your tracing. And second thing is you want to do is end-to-end encryption, and it just helps very secure. The last thing I always say is secure whatever you see. See everything. See everything. Don't lose anything in small pieces. Make sure you see everything and you monitor everything and make sure it's secure everything. That's it, guys. I'll stop here. I'll see. Is there any
Awesome, Santosh.
questions?
Thanks for your sessions and information. I think
Thanks, mate.
we covered a couple of those networking services which have the security feature, and they are very close to my heart. So thanks, thanks for covering those. And I think you mentioned one of those questions which I'll bring it up. Nico
Yeah.
just mentioned it's important to use the prevention
Oh,
versus
yes.
that.
That's
I
correct.
think you covered that pretty
Yeah,
much.
Nico.
You are
Thanks, Nico.
completely
Even
right.
I don't want to miss it. That's a great question and this great point actually. How to make sure it's always been protective mode.
Yeah, and maybe the second question is from Pablo, which is he's asking for a guidance. What's your
Yeah.
suggestion on this?
See, mate, again, it based on the business goal. The last slide, which I explained, right? Your starting point, just go and make sure which is your business goal. If it is just purely a web load balancing, front door. If you want to have something addition to that, then front door plus application gateway with the WAF. Just front door with WAF is what I would pretty much recommend because if it is on front door, it can act across the globe. It can be active, passive, and top of that enable WAF.
Awesome. No, yeah, exactly. I think yeah, different business requirements. What's going to be behind of that infrastructure, all of those elements, and sometimes it's coming to the business requirements, especially when it's coming to the cyber and
Correct.
security from the security lens perspective. Which one of those really actually the best use case to use?
Yeah.
And you covered very well. I'm agree. It's the same as a lot of other Microsoft services. You need to
Yes.
go through that tree and
List.
find out actually which one is going to be best use of.
Yeah.
I was talking with some friends about the AI and those
Yeah.
things, and which AI services of Microsoft in Azure or any other places should be used.
Greatest to be
It's pretty
used.
much going back to exactly what's
Yeah.
the use case really? Yeah.
Yeah, what is
So
exactly the use case, and Microsoft has some good document to have that last slide, pretty much a large slide, right? That slide has been done by Microsoft. What is your starting point? Which are services available? What is your business goal? Just align to that. That's it, pretty much.
exactly, and you covered actually a couple of networking services, and maybe a question, high level type of questions, I would
Yeah.
say, is what's your view actually how these services can be integrated with each other to cover the principles that we are normally looking into the zero trust architecture?
Yep.
And what's your actually view on that?
Yeah, my zero trust architecture is my favorite, mate. See, the first thing is network segmentation. Make
Thank
sure you stop your lateral movement, making sure based on your application requirement, you just do a segmentation. That's the first thing. And second thing is do an end-to-end TLS encryption from the client browser to the backend. Make sure it's TLS enabled. You can, for the TLS one, you can use front door plus WAF. If it is a global service, you want to make sure everything is a CDN and content available, then front door. If you are just regional based, then I would say Azure Application Gateway. Just please be in mind that Gateway is just being a regional service. You can't have an auto instant failover with that way. So front door takes up that way with the WAF, with the MTLS or TLS, making sure that's way it's secure enough. That's these are the things. And again, if you want to go in deep diver, then enable private link from your front door to your backend resources. Don't have it as a public endpoint. Make sure it's private endpoint and you have private link enabled so that all the traffic is just being privately on the backbone. It's nothing on the public backbone of the Microsoft. Even though it's a Microsoft backbone, we just want to make sure it's been ensured with the security of higher severity.
Oh, very valid point. Very valid point. I think that's wherever you don't need to expose any of your services to the internet, why you should have
Yep.
it publicly available. So
Exactly.
you have to go to that private endpoint and private link, and that's completely
Yeah.
makes sense.
Yeah.
So I'm totally sure none of the session is going to have without AI questions type of questions. So maybe the next question from me is, how do you see the AI and automations in the future of the Azure network security services from your own perspective?
See, again, as part of you and me are from cloud security in the Azure MPs, right? We see a lot of analytics and monitoring happening on the AI side of the part, which pretty much helps us to do in Sentinel, get the logs collected, aggregate that, and correlate it, and provide you a different dashboard, which helps it. Sometimes we probably, as a human, right, we sometimes we miss it some scenarios. That way, it helps it actually just boost you the value. But again, it's a long way to go into the networking side. But mostly I see that is on the log aggregation with log ingestion, which helps that way to have minimized void.
Yeah, from my own perspective, I was just saying actually that would be great to see the adaptive protection in the network security services
Yes.
too. So before was very based on the pattern, or still is a lot of those services, network services especially, they are pattern based type of actually security controls in
Yep.
compare with maybe that when his AI is coming, probably the real time is just
Yeah.
analyzing the traffic's passing through and just have adaptive protection in place.
Yes.
I would love actually to see that's happening because I'm totally sure is those fixed firewall policies, those fixed type
Fixed.
of NSGs
away.
and those things in Azure is going to be changed.
Change.
The whole scope. That's my hope actually for the future of using
Yeah,
AI in that.
that's lovely, man. Yeah, that's I totally agree with you. Looking forward to
Yeah.
those kind of scenarios comes up.
Definitely. Okay, great. Thank you again, Santosh. I think it was a great session.
Thanks for
Lots of
having again.
great information. Great.
Thanks.
Thank you everyone for joining. Looking forward to have the next sessions with the other great MVPs in APAC region. So have a great night, great morning, great evening, wherever you are, and see you later.
Thanks, guys.